Now I want to talk a little bit about the idea of the graphs of the derivative functions. I showed you one a little bit earlier where I graph both the original function and the graph of the derivative to see what the derivative tells you about the function. So I want to do it again for f of x equals x squared. So I'm going to graph the original function along with the derivative function and just talk about how they're related to each other. So first I need to find the derivative of x squared. So I will take the limit as delta x goes to 0 of x plus delta x squared minus x squared over delta x. That equals the limit as delta x goes to 0. When I expand this, I will get x squared plus 2x delta x plus delta x squared minus x squared over delta x. Now the x squareds will go away. This delta x will cancel with this one and one of those. So what I end up with is the limit as delta x goes to 0 of what's left, 2x plus delta x. So now I can let delta x go to 0, and when it does, this limit is simply 2x. So let's take a look at the function f of x equals x squared along with the function f prime of x equals 2x, and see what that's actually, or what this is actually telling me about the original function. So here we are back in Maple, and I want x squared, and I want the function 2x, and x equals, let's just say, let's go negative 10 to 10, y equals negative 10 to 10. We'll make an adjustment if we need to. And I want to add this to make it a little bit thicker. And let's make the function a little bit bigger, or this graph a little bit bigger. Okay, let's take a look at this and see what it's doing. And actually, let's go. I'm going to change this a little bit. I guess really negative 5 to 5 is pretty good on the x-axis. There we go. That's a little bit better picture. Okay, so just what is it that's actually going on here? Obviously, this is x squared. This is a parabola. And this is the derivative function. Now, I want you to think about this for a second. If I'm up here someplace, the slope is going to be negative, correct? As I move along, the slope will stay negative, but it's going from very steep to almost horizontal to actually horizontal right here. Well, the values down here on the derivative are negative. The slope is negative, but the value is getting smaller and smaller and smaller. It's approaching 0. And actually the value of the derivative is 0 at this point here, the vertex of the parabola, because the tangent line would be actually the x-axis. So when I go past the point x equals 0, my slope, if I drew a tangent line in here, would be positive, and it continues positive. It gets bigger and bigger and bigger, and that's what my derivative function is doing. It's getting bigger and bigger and bigger and bigger, which matches the slope of this function. So with that in mind, I should be able to come over here and let's just pick some function. Matter of fact, I don't care what the real function is. I'm going to make something up. Let's just go ahead and stop it over here. That's good enough. This should give you a good idea what's going on. So this is just some function. And what I want to do is I want to say, all right, what would my derivative function look like? Approximately. Well, I can see right here that any tangent line, or the tangent line, would have a slope of 0. I can see right here that a tangent line would have a slope of 0. So right away I know that my derivative function will be 0 here, and it'll be 0 here. Now my question is, what's going on over here? Well, prior to this point, everywhere on here, any point I pick, I'm going to have a positive slope. So that tells me that my derivative function must be positive. It's up here someplace, and it comes down to here. Now the question is, at this point, what happens to the slope of my tangent lines? Well, as soon as I pass over here, moving x this way, all my slopes are going to be negative. So that means that my derivative function must also be negative. So it's going to come down. Now you notice at some point here, it's kind of difficult to tell exactly where, it doesn't really matter, but at some point here I switch from this downward curve to an upward curve. And when that happens, that's when my negative, it's going to still be negative, but I'm going to switch here from going down to starting back up. Now notice my slopes are still negative. All these slopes are negative, as is this function. This function continues negative, and it will get smaller and smaller and smaller, as in getting closer and closer to 0, until the slope of my original function's horizontal. Now my derivative function is up here. Now beyond this point, I can tell that all of my slopes are going to be positive. Every one of these guys, I didn't draw that very good, but every one of these guys are positive. So my derivative function will continue on. So this is f prime of x, with this being f of x. Now this is not going to be exact, but it's just a rough drawing. The point is, when I look at this function, I can tell what my derivative function should be doing. And likewise, I should be able to go the other way. I should be able to simply draw a graph of what I'm calling a derivative function, and based on that derivative function, come up with a rough representation of what my original function looks like.